So for example number 2, we're told that, and they give us a map, but we're told that the map shows the number of tickets needed for small or large rides at the fair. You do not want to spend more than $15 on tickets. How many small and large rides can you ride? So what they said is, okay, look, we don't know how many small rides we have, and we don't know how many large rides we have. But what we know is that we don't want to spend more than $15. Now, the way that I would write that is less than, does it say that we can spend $15?
Don't spend more,
So don't spend more than $15.
So you can spend 15.
So it's equal to,
right?
Right.
So less than or equal to 15.
Correct.
Yeah.
But it says the map shows the number of tickets for you don't want to spend more than $15 on tickets. Then it says how many large and small rides can you ride? Oh, there's one other thing. It says that for $15 you can actually, there's one little thing. It says for $15 you can actually get 60 tickets. And it says that it's 1 ticket per ride.
So you're going to be spending $15.
So if you spend $15, how many tickets do you get?
60.
60. So we're gonna say less than or equal to 60 tickets if we solve based on tickets. Why would I do that? Because the rides are based on the ticket,
Not the money.
not the money. So we're gonna do like a little conversion thing. Well, how many small rides can I ride? X. How many large rides? Y. How many tickets do I have?
60.
60. So now here I have a way to represent the large or small tickets, or large or small rides, which cost a ticket each. So I've got X comma Y. And I'm going to graph that. Oh wait, it's not a ticket per ride though. I forgot to mention that for a small ride it's actually 3 tickets.
Dang.
And for a large ride, I think it was 5 tickets. So technically, we've got this inequality. So yeah, and so to graph this, what do I, it's in the standard form, but what do I want it in?
You want to solve for X.
Yeah, I want it to look like this. I want it in slope-intercept form, yx plus b, or y equals mx plus b. So what I do is I start with this, and then I solve. I'm going to subtract 3x from both sides. And these cancel and I get 5. Y is less than or equal to 60. Actually, let's write it like this. Minus 3x plus 60. Then I'm going to divide everything by 5. So I get y is less than or equal to negative 3/5 x plus 12. So now to graph this thing, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to come down 3 and go over 5. So I'm going to come down 1, 2, 3 over 1, 2, 3, 4, 5, 6, 5, about right here. Solid or dotted line?
Solid.
Solid line comes across like this. Now, do I shade above or below the line?
Below.
We would think that you would go below the line because the y value has to be less than the line. But we want to test it just to make sure. So how do I test that?
0, 0.
0, 0. I'm going to use the test point 0, 0. So I'm going to test using 0, 0. So what I would do is I would say 3 times 0, right? Because this is 0, comma 0, which is x comma y, which means x equals 0 and y equals 0. So I'm going to say 3 times 0 plus 5 times 0 is equal to, or less than or equal to 60.
Yes.
Yeah, that's true because this whole thing is 0. So this is true. So all this stuff here is my solution set. So if I pick a point anywhere in this shaded region, that would satisfy that inequality. Does that make sense?
Mm-hmm.
So let me give you an example. let's pick a point. I'm going to pick a point over here. We'll say that that point is 5, 0. That exists in the shaded region, right?
Yep.
So that says that I could ride x equals 5, or I could ride 5 small rides, and 0. Well, actually, let's change that. Let's go up 1. Let's ride 1 small ride, right? And 1 small ride. Large. And I should still have some tickets left over, right? So if I say 5, 1. Well, if I plug that in, I've got 3 times 5 plus 5 times 1 is less than or equal to 60. Well, 15 plus 5 is less than or equal to 60 because I get 20 is less than or equal to 60.
Yeah.
Does that make sense?